All right, today in geometry, we're going to review our basic radical skills. So let's recall some vocabulary. So first, recall the radical, okay? That is the symbol itself. The radicand, that is the number underneath the radical. The index, that is the number or the root of the symbol. Perfect square, that's the product of a rational number multiplied by itself. So then let's review what is a rational number. A rational number is a number where the decimal terminates or repeats a pattern. Remember, terminates is just a fancy way of saying stops. So where it terminates or repeats a pattern. And then we'll give some examples of that. So an example where it terminates, like 1/2, right? Because 0.5, the decimal stops. 3/4 is 0.75, it stops. The number 5 is a rational number because it's 5.0, it stops. 1/3, 0.33333, repeating it repeats the exact same pattern over, so that is also considered rational. So we're going to just identify the index and the radicand of each radical given. Let's practice these. So we have the square root of 15. The index is the root. It's a square root, so square is 2. So the index is a 2. The radicand, that's the number underneath the radical symbol itself, 15. Next one, the fourth root of 271. The index, it's the number up here, so the index is 4. And again, remember over here, the index is that root. When there's not one written, it's understood to be a square root and understood to be a 2. So back to the fourth root of 271, my radicand is 271. The next one, 3 times the fifth root of 32. The index is that 5 up there. The radicand is their 32. So we're going to simplify radicals using the factor tree method. The steps. First, we're going to list all the factors of the radicand. Second, we can use what I like to call the buddy system, and we will circle all the pairs of buddies of factors. Okay? That just means circle the 2 that are exactly alike. Each buddy or pair will come outside the radical one time. If you have more than one pair, then the pairs get multiplied together outside. Anyone without a buddy or a pair will stay underneath the radical or inside the house. If there are more than one number staying behind, you will multiply the numbers together. Okay? So the buddy system is kind of like, think of the radical as the little house. In order to go outside and play, they have to have a buddy, but their buddy has to be exactly like them. So number 1, the square root of 42. We're going to just start breaking it down by its factors. What can I multiply together to get 42? 7 and 6. What can I multiply to get 7? Just 1 and 7. So that is down as much as it can go. 6, I can break that down to 2 and 3. I can't break down anything else, so I have a 7, a 2, and a 3. None of them have pairs or buddies, so this is already simplified. The square root of 42 is as much as I can take. Number 2, the square root of 108. So what can I multiply together to get 108? It's an even number, right? 108 is even, so if it's even, I know at least 2 is going to go into it. So 2 goes in there 54 times. So now let's break the 54 down. That is going to be 9 and 6. 9 breaks down to 3 and 3. 6 breaks down to 3 and 2. So now I'm ready to get buddies, okay? I have a pair of 3s, so they're buddies. This 3 gets left behind. He doesn't have another 3 to go with them. I have this 2 and this 2 are buddies. So I have a 3 that comes out. I have a 2 that comes out. And then underneath my radical is this lonely little 3. Anything that came out together gets multiplied together. So 3 times 2 gets me 6. Square root of 3 left behind. So my answer is 6 square root of 3. Let's turn our paper over and look at number 3, the square root of 72. Again, we're going to break that down. So 72 came from 9 times 8. 9 will break down to 3 and 3. 8 breaks down to 2 and 4. 4 breaks down to 2 and 2. So now we're going to look for buddies. I have a pair of 2's here. I have a pair of 3's here. That 2, no buddies. So what comes out? A 3, a 2. What gets left behind? A 2. So this is also 3 times 2, 6 square roots of 2. Then it just reminds us that when there's a number that's in front of the radical to begin with, you will simply multiply that number with any pairs that come outside. So we're going to look at number 1, 2 times the square root of 54. So we're just going to do factor tree on the 54. I know that came from 9 and 6. 9 breaks down to 3 and 3. 6 breaks down to 2 and 3. So now I'm looking for my buddies. I have a pair of 3's. This 2 doesn't have a buddy, this 3 doesn't have a buddy, so they both stay behind. I already had this 2 on the outside, so I don't forget about him. So I add a 2 on the outside, this pair of 3's comes out. What got left behind was a 2 and a 3. We always multiply. So out front, 2 times 3 gets me 6. Underneath my radical, 2 times 3 gets me 6. So my answer, 6 square roots of 6. Number 2, negative the square root of 104. So let's break this down. Again, it's an even number, so I know 2 goes in there 52 times. 52, I can break that down to 2 and 26. 26, I can break down to 2 and 13. I have a pair of 2's here. This 2 and this 13 don't have any buddies, so they stay behind. I already had this negative on the outside. So I have negative on the outside, and then my 2 comes outside. Underneath my radical is a 2 and a 13. I have to multiply them together. So negative 2 on the outside, square root of 26 left behind. There's our answer. Number 3, negative 2 times square root of 81. Okay. 81, that breaks down to 9 and 9. I could break 9 and 9 down again, 3 and 3, but remember I'm just looking for a pair of buddies. So right here I have a pair of buddies at 9, so I can stop. Is there anything left behind? No. That's because the square root of 81 is a perfect square, right? The square root of 81 is 9. So this just turns to negative 2 on the outside, my 9 that comes out, multiply together, and I get negative 18. No more radical, and that's fine. So if we had a perfect square underneath our radical, we're not going to have any radicals left. So that is a quick review of our basic radical skills. Your homework today will cover all of this, and then tomorrow we'll do a little bit more with radicals.